So yeah, so NVIDIA announced the DLS5. It's actually DLSS 5. It announced it like a couple of days ago, and I think it's interesting. It's something new that NVIDIA launched, and I think like it's future of gaming. But many people has like different opinion about this because of the graphic fidelity. It looks realistic. However, it look way more realistic than we are used to play, because some games like I used to play with, like they have moderate graphics, but these kind of games now, this is like using the DLSS 5. It's kind of changing the gameplay. It's like a movie. So we are playing movies right now. So we're not playing video games. We're playing movies, and this is kind of weird because we don't have to play movies. We are used to play video games. I can watch the movie, so I would have to play a movie as a video game. But anyway, the graphics are amazing, except the faces. Like our characters' faces and the like facials are not as really realistic. Some faces, like in the trial, I'm gonna show you the trial right now. Some of the faces, like they look pretty much more like realistic than the normal mode without the DLSS 5, and some of them they look like kind of weird. Okay, so yeah, this is like the new NVIDIA feature. It's announcing a couple of days ago, NVIDIA DLSS 5, a breakthrough in visual fidelity for games. So if you want to check the website, you can learn about it. But I had read a little bit about it, and I think it's pretty interesting to use the AI. It's like integrating AI with the video game, so you can have both features. And from what I understood, that AI is kind of predicting the next frame, so it gives you the realistic, realistic texture and the realistic lighting. And I think lighting has the most like the most effect on the using this DLSS 5, because if you look at the difference between those, you can see the lighting, right? So yeah, the lighting is has the most feature where it's look more realistic than the other one without the DLSS 5. So let's look at this. What Oh, first of all, what is DLSS 5 means? So let's look at this. I have it stands for Deep Learning Super Sampling 5. So it's next generation AI, blah blah blah, or neural rendering technology. And it's not announced. It's announced, but it's not. We cannot use it yet. We have to wait until perhaps fall of this year. And yeah, there are some couple of games. It covers like targeted performance, photorealistic and materials. Supported games like they were gonna have announced for major titles. We have Starfield, Assassin's Creed, Shadows, Hogwarts Legacy, Resident Evil Requiem, and Elder Scrolls. Oblivion Remaster, yes. So DLSS 5, okay. So I had to run some. I brought in ChatGPT. What's this thing? It's actually uses AI to upscale the lower resolution frames and generate additional frames and predict the motion between frames. Okay, sounds interesting. But what if we have a video game with very low quality of animation? Like, you remember the old video games, like where they didn't have a very good animation. So how do we fix this? Like, it's gonna look very weird if you have like this video game with lower animation, and at the same way as at the same time it's really realistic. So it's gonna render unrealistic animation with a realistic textures and realistic lighting. It's gonna be like, okay, realistic game but not realistic animation. So how are they gonna figure that out? And is this gonna be like is this gonna be a good feature? Are people gonna like it? Are people not gonna like it? I don't know, because perhaps they're gonna tweak it. Perhaps they're gonna fix it, like perhaps downgrade a little bit of this lighting, like see here. Uh, yeah. Anyway, let's watch the video here. Okay, let's watch the video. There we go. Okay. This is from the Resident Evil. I didn't play this game yet, but look at the difference. Look at the difference here. This feature kind of changed, uh, like the character. Like we are used to play with this character, and like we have this filter, and it changed the character. Like it's a different person right now. It's like different character, different protagonist. Like look at this. Oh, here we have another one. Here we have a different one. But to be honest, I'm gonna be fair. Like, look at the lighting; it's way more realistic, way more interesting. Like, it looks really good here. But I'm not sure about like people opinions. Like, I don't know. Like, some people like they think like this is a little bit slob. We don't like this. We're used to AI. Like, it kind of looks like the Snapchat filter or anything. But I would like to play the game like this. You know, I don't have to like worry too much about my character. If my this character, I know it, I know her perhaps, and they kind of change the lighting and the texture look way more realistic. I don't mind, but perhaps they have to tweak it, perhaps downgrade a little bit here, the lighting here. Uh, yeah, this is what I think. But overall, like it's a very good feature, and I think Nvidia is doing a great job here. And from an architect opinion, I think like this is really good for us also, architects and designers. They're gonna use this, and I think like this is coming to also another programs, 3D programs, that they have this feature DLSS 5 turned on or off. And it's fair that for the upcoming video games, if you have this DLSS 5 turned on and off, I think it's fair. Like people whom they don't like it, they can turn it off, and people who likes it, they can keep it. So this is not very big deal. I think like it's a good effort from NVIDIA to show this to us. Okay, NVIDIA are doing great job, I think. But let's see how people are gonna react. People think this is like the AI pictures. Like people are used to see a lot of ads and AI pictures, and they don't like it. Perhaps this has like affected the people opinion about the AI overall. But we have to wait. Okay, so let's watch the whole trailer here. So this is Resident Evil, and this is Leon. Okay, look, Leon looks great here from Resident Evil. Like it looks really good. There's improvement in lighting and sharpness here, some details. The atmosphere, it's raining. It looks good. It looks really good. Like I don't know what some of you they think that this does not look really good, but I think it looks good. But here's here where people think this is awful. Yeah. To be fair, yeah, they are right. This looks awful. Like I think in this character in this video game, the developers like they had to make a lot of details here to show this lady's wrinkled skin. They add many wrinkles here, so when we use this DLSS 5, I think it does like do a very good job here. So perhaps they have to downgrade this a little bit, and I think it's gonna be fine. I think it's gonna be a good tool, and I'm excited to try it. To be honest, like I like it. I like it. You know. This is Hogwarts, and this is Starfield. Starfield looks great. I think Starfield is among the best ones so far. Okay, look here. This is the normal one. Here is after adding this effect. Wow. Okay. Well, here is like I don't know. I think there's some uh, something is not going well here. Yeah. Okay. Well, like it's solid. It's good. It's good. Let's watch another one. Perhaps here. Okay. Well, we don't want this now. So yeah. What do you guys think about this? Really? Oops. I think I wait a second. Need to fix some stuff in here.
The 20th.
Just fixing my camera here. Okay. Yeah. Thank you. Okay, voila. All right. Okay, we're back. Okay, let's watch another video from NVIDIA.
Anniversary of CUDA. We've been working on CUDA for 20 years. For 20 years, we've been dedicated to this architecture. This
Yo, my internet is lagging a little bit. Okay.
How far can your apps go? Meet Base 44. Prompt it. Foundation.
Okay, are we done now? Can we play the video yet? Oh my god. Okay, let's try now. Okay, well, I have to wait for this sloppy internet. God damn. Okay, let's read some stuff here. Uh, so this is how NVIDIA explained it. So DLSS 5.5, bridging the cinematic gap, availability in game developer. So yeah, okay, whatever. Here we have the like chart. Try to explain. how they have this results. So after the DLSS 5, they have this result real-time 4K graphic. Yeah, for people who understand this, maybe you can explain this a little bit to me. But it's supported by the industry biggest publishers and game developers, including Bethesda, Capcom, and other studios here as well. And it will arrive this fall. And see the first preview this week. It was the first preview at the GTC, and below you can check out the several examples of NVIDIA series in the EVO Regulum, EA Games, EA Sports, and Starfield, Hogwarts Legacy, and NVIDIA Tech Demo. Well, well, this is not bad. This is not bad. This is really cool. Look here. Oh, look here. Look, I don't know. Like some frames, like look at this. Here, this is the original, and here the DLSS 5 on. But if you look at this one, you have totally different characters here. Like we have 1, 2, and 3, 4. I don't know. Like I think like there are 4 different individuals here. But uh, maybe this character only. But here, I think like the difference between the off and on for the DLSS 5, I think here looks way better than this one. You see, like this is really different here. Like the nose, the mouth, the eyes, the eyebrows, even the hair, right? Here, like here we don't have anyone's walking. Here we have some people walking. There's some stuff are changing, right? So I don't know how this gonna work. Like the game, the game like has already 3D characters, and this AI kind of like delete those characters, like add some project, perhaps add some models. But I would not say I would not say no. This is awful. No, this is good. I would like to play a game like that. But I don't know. I've never played a game like this. I never had has this. Uh, I don't know. My eyes can like will deceive me. Like I think my eyes are not accustomed to see something like that and play something like that. Usually I watch a movie, but I don't know. I need to try it. I'm excited to be honest. Look here. Look at the you see, like the tiles. There are not so many changes here on the tiles, and the background looks the same, but the character and the lighting, I think. Here's Neo. The lighting, man, looks amazing. That's the here is FIFA. See the crowd here with the DLS, here without DLS. See the ball and the crowd. Here without it, here with it. So, yep, here and here. Starfield, same thing. Starfield looks the best. You see a little bit like the same frame, changing like the position of the character. Not the same position, but I've never seen this before. You see, like, you see, like you kind of tilt her head a little bit to the left. I don't know. Let's go check out another ones. Okay. Well, like definitely, this frame looks way better than the other frame. Way more realistic. Let's see Hogwarts. Okay. DLSS 5 is coming to Hogwarts Legacy. Okay. That's like that. Oh, this looks awful. Okay, here. Maybe this one not too great. Okay. Let's see here, maybe. Zora. This is like a demo. This is a demo. Okay, let's see this demo.
The AI Toolkit is live on Artlist. Every leading AI tool you need for video creation is now organized for you.
It's like definitely looks like one of these.
All that
Like Artlist or something. This is what we are playing. We are playing Artlist. Wow. Oh, I mean, everything looks bad. Texture, material, lighting. Oh, I love this. I really like this. I know why so many people have different opinion about this, and I didn't like it, but I think it's really cool. I mean, like if NVIDIA gave us this feature, and but I hope that video games will not be more expensive, and because like I don't know, this needs some RAMs, perhaps the performance is gonna be the same. Are we gonna have issues with frame rates? It's gonna boost our frame rates, or it's gonna make our frame rates suffer? I don't know. So this is the examples we have, and let's go back to the main one. Okay, let's see this. Okay, uh, on Starfield. No, we saw that. Sorry. Yeah, so that's yeah. This one. I like to see this one, just to have an opinion on it. Okay, look here. The same hair. Hmm. Here's Neo riding his vehicle. Well, hmm. Okay, with this NVIDIA, that's the new tool. That's the new thing that they launched, and I think is gonna be the future of video games. Everybody is gonna talk about this. Everybody's gonna hate it or like it. We have to wait until NVIDIA add this feature to its games, and perhaps on PlayStation 6, perhaps I don't know, on this version of PlayStation 5, we're gonna have this year. I hope it's gonna be a cool feature. I hope people are gonna like it. I'm gonna see better performances and not the frame rate issues uh, and bad animations. So it's gonna be out this fall. And yeah, photorealism. Let's see this one. Let's see. Oh, look, like for example, this looks amazing. I don't know. None of you can tell me this one does not look amazing. This looks really beautiful. Like this is like on. This is off. This is on. Look at this. Look here. Look like this is coming off like the feeling, the background. Really looks really good. Okay, let's see what this guy has
For
to say
20
about
years,
this.
we've been dedicated to this architecture, this revolutionary invention, SIMT, single instruction, multi-threaded, writing scalar code could spawn off into multi-threaded application, much, much easier to program than SIMD. We recently added tiles so that we could help people program tensor cores and the structures of mathematics that are so foundational to artificial intelligence today. Thousands of tools and compilers and frameworks and libraries. In open source, there's a couple of 100,000 public projects. CUDA literally is integrated into every single ecosystem. This chart basically describes 100% of NVIDIA's strategies. You've been watching me talk about this slide from the very beginning. And ultimately, the single hardest thing to achieve is the thing on the bottom, installed base. It has taken us 20 years to now have built up hundreds of millions of GPUs and computing systems around the world that run CUDA. We are in every cloud. We're in every computer company. We serve just about every single industry. The installed base of CUDA is the reason why the flywheel is accelerating. The installed base is what attracts developers, who then creates new algorithms that achieves a breakthrough. For example, deep learning. There are so many others. Those breakthroughs leads to entirely new markets, which builds new ecosystems around them with other companies that join, which creates a larger installed base. This flywheel,
I don't know, like, they
is
are
now
working
accelerating.
really good.
The number of
They have
downloads
really,
of NVIDIA
like,
libraries is incredibly
good
accelerating.
project for the
It's
future,
at a very large
and
scale and
I
growing
think NVIDIA is
faster
doing
than
really
ever.
well.
This flywheel is what makes this computing platform able to
Despite
sustain
everything that's
so
happening
much
now around the
applications,
world, but I think
so
NVIDIA,
many
like,
new
has
breakthroughs,
potential
but most importantly,
to do many great things.
it also enables these infrastructures to have extraordinarily useful life.
Okay.
And the reason for that is very obvious. There's so many applications that you can run on NVIDIA CUDA. We support every single phase of the AI lifecycle. We address every single data processing
So how
platform.
much are going to be the
We
GPU
accelerate
cost?
scientific principled solvers of all different
How
kinds.
much the cost now
And so the
in
application
thousands
reach is so great
to be able to
that
afford like
once
a GPU that
you
runs
install NVIDIA
this
GPUs,
DLSS
the
5
useful life of it is incredibly
or
high.
only AI?
It is also one
Hopefully
of the reasons why
only AI.
Ampere that we shipped them some 6 years ago, the pricing of Ampere in the cloud is going up. And so all of that is made possible fundamentally because the install base is high, the flywheel is high,
I don't know.
the developer reach
What do
is
you guys
great.
think?
And when all of
Do
that
you guys
happens,
love
and we
this?
continuously
Do you guys
update
like
our
it?
software,
Would you try it? I
the
don't
computing
know.
cost
Would like if NVIDIA
declines. The
asks you to
combination
charge
of
you a little
accelerated
bit
computing,
to
speeding
buy
up applications
those,
tremendously.
perhaps I don't
Meanwhile,
know,
as
buy
we continue to
new
nurture
things
and
for
continue to
this
update software over
feature
its
to
life,
work, buy
not
new
only do you
RAMs
get the
maybe. I
first
don't
time
know.
pop,
Would
you
you
get the
like it? Would you
continuous
turn it
cost
on? Would
reduction
you turn it
of
off?
accelerated computing over time. And we're willing to nurture,
Let's
willing
see
to
what happens
support
this year.
every single one of these GPUs in the world because they're all architecturally compatible. We're willing to do so because the install base is so large. If we release a new optimization, it benefits millions. This applies to everybody in the world. This combination of dynamics is what makes the NVIDIA architecture expand its reach, accelerating its growth, at the same time driving down computing cost, which ultimately
What do you mean by driving
encourages
down
new growth.
computing
So
process?
CUDA is at the center of it. But our journey to CUDA actually started
The
25
price
years
of RAMs
ago.
are like
GeForce
more than ever. This is the RTX 20.
I know how many of you grew up with GeForce. GeForce is NVIDIA's greatest marketing campaign. We attract future customers starting long before you could afford to pay for it yourself. Your parents paid. Your parents paid. Your parents paid for you to be NVIDIA customers. And every single year, they paid up year after year after year until someday you became an amazing computer scientist. and became a proper customer, a proper developer. But this is the house that GeForce made. 25 years ago, we started our journey, which led to CUDA. 25 years ago, we invented the programmable shader, a perfectly unobvious invention to make an accelerator programmable, the world's first programmable accelerator, the pixel shader. 25 years ago, that led us to explore further and further. 20 years later, 5 years later, the invention of CUDA. One of the biggest investments that we made, and we couldn't afford it at the time, and it consumed the vast majority of our company's profits, was to take CUDA on the backs of GeForce to every single computer. We dedicated ourselves to create this platform because we felt so strongly about its potential. But ultimately, the company's dedication to it, despite the hardships in the beginning, believing in it every single day, for 13 generations of 20 years, we now have CUDA installed everywhere. The pixel shader led to, of course, the revolution of GeForce. And then 10 years ago, we introduced, about 10 years ago, what is it, 8 years ago? We introduced RTX, a complete redesign of our architecture for the modern era of computer graphics. GeForce brought CUDA to the world. GeForce, therefore, enabled Alex Krizhevsky and Ilya Sutskever and Jeff Hinton, Andrew Ng, and so many others to discover that the GPU could be their friend in accelerating deep learning. It started the big bang of AI. 10 years ago, we decided that we would fuse programmable shading and introduce two new ideas: ray tracing, hardware ray tracing, which is incredibly hard to do.
It's true.
And a new idea at the time.
Latest achievements
Imagine,
was,
about
RTX
10 years ago, we
shaders,
thought that AI
now
would
they're
revolutionize
bringing
computer
AI
graphics.
to it.
Just as GeForce brought AI to the world, AI is now going to go back and revolutionize how computer graphics is done altogether. Well, today I'm going to show you something of the future. This is our next generation of graphics technology. We call it neural rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS 5. Take a look at it.
That's really interesting, this feature.
My work is easy because I use ClickUp. Here's how I keep track of all my tasks.
Please.
I start by brain dumping everything I need to get.
Whatever. But some of them looks great, some of them not that great. But let's see what Jensen has to say here.
Is that incredible?
It is incredible.
Computer graphics comes to life. Now, what did we do? We
Watch
fused
a movie.
controllable 3D graphics, the ground truth of virtual worlds, the structured data. Remember this word, the structured data of virtual worlds, of generated worlds. We combine 3D graphics, structured data, with generative AI, probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly realistic. We combine these two ideas, controlled through structured data, controlled perfectly, and yet generating at the same time. And as a result, the content is beautiful, amazing as well as controllable. This concept
Well,
of
this is really
fusing
interesting. You're
structured
playing something basically
information
playing like a
and
movie.
generative AI will repeat itself in one industry after another industry after another
We're playing
industry.
a movie.
Structured data is the foundation of trustworthy AI. Well,
I don't know. What do you guys think? Let me know. I think it's a cool feature. Let's see what happens. Yeah, I think I don't know. We're playing movies now.